So welcome. My name's Brian Thomas. I'm here to kind of do a GED review, and this is going to be for the data, statistics, and probability questions. Again, the GED is more about math reasoning, so your reading ability is very important. And when it comes to the data, statistics, and probability, you'll start to see a lot more graphical information. So again, we still have to focus on what we know, what we're looking for, the unknowns. We're trying to figure out that relationship. A lot of times we're looking for some type of formula or some type of clue in the problem that gives us that relationship. An estimate can be used to help us kind of narrow down some of the answers. Again, of course, set up and solve, if we can't uh, get a really good estimate, then there's going to be a reason to really set the problem up and solve it. And that's where your math skills come in as well. So reading and then the ability to actually do the math, either using a calculator or a combination of paper and the calculator. And once you do solve the problem, always look back at your answer and see if it actually fits the problem. It makes sense. So let's go ahead and look at this first question here. So we have a graph. It's about, again, the title of the graph is important to us. American aircraft, orders of new planes, 2005 to 2010. Over here on the left side, we have some numbers here that represent the number of planes ordered. So it goes in increments of 100. And then across the bottom, we have these different years. So it kind of mimics this 2005 to 2010. And this is actually what's called a bar graph because you have these little bars of data. So again, you mainly just want to kind of glance at the graph, and then you want to just come down here to the question, see what part of the graph we need to focus on. So the graph says by about what percent did orders at American Aircraft decrease from 2008 to 2009? So again, this is a percent question. So I'm already kind of thinking, can I use my triangle model to solve this? So we have in the triangle model for percents, the top part is what we call the part or the portion that we're dealing with. This area here is referred to as the base or the whole amount. It sometimes is what we refer to as the original amount or the initial amount. So some concept of all of it. And then here is where the percent drops in into that spot. And remember, the part and the base, those two values are going to be related by division. And if you divide the part and the base, what that's going to give you is the missing part would have been the percent. So if you divide the part and the percent, if they were the known ones, the part and the percent, if you divide those, that's going to tell you what the original amount is or the base amount. And then the base and the percent, if you multiply the base times the percent, the whole amount times the percent, that's going to tell you the part. So those are going to be the relationships laid out in our diagram. So when I do this problem, I can kind of, hopefully this problem will fit into this dynamic. Most of them do. So it's talking about this decrease. So we're looking for the percent and that it decreased by. So if I look at 2008 in the graph, it looks like that's around 650. So I can make a note of that. And then in 2009, we kind of noticed that the numbers went down, the orders went down. And it looks like a shade under 400. So I may say like 390 there as an estimate. Now, what they want me to do is find this decrease. So using my calculator, I can go 650, take away the 390, and that actually gives me a 260 decrease. So the number of orders actually went down by 260. So that's going to be my part, the 260. And again, notice that we're looking for the percent. So what must be given is the base amount must also be given. So the base amount, remember, is also the initial amount. So that's referring to the 2008 was the initial amount of orders. So we said that was around 650. So using that model, this tells me I can actually divide to solve that. So using my calculator again, this 260 is going to be divided by the 650. And this is going to give me then 0.4. Now remember in this model here, that when you use the triangle model, you still got to move your decimal 2 places to the right. So once I get this 0.4, you still got to move the decimal 2 places to the right, which ends up making this 40%. 40% would be the same thing as 40 hundredths. So this is like 0.40, if you will. So 40 hundredths is the same thing as 40%, because that's what 40% means. So that leads us to then B, 40%. Again, as we talk about, it's hard to do estimates when I'm not really comfortable with percents to begin with. But one thing we kind of pick up on though is, 1% I'm kind of familiar with is like 50%. And, just looking at the graph, this looks like about half as much as this. So I'd be guessing around 50%. So, 75% would be one I would drop, but I would not be confident in dropping the other three without doing the math. So the estimate still isn't going to get us very far. The math still has to be done to solve this problem. So let's see if we can clear this up and look at our next question. So at a state fair, Harry and his 3 friends each bought 3 raffle tickets. At the time of the drawing, 400 tickets had been sold. What is the probability that either Harry or one of his friends will win? And just look at the answers, we kind of see that this is a fraction concept. The way this fraction works is, again, you have to have what we refer to as the we have what's called like your possible outcomes, or the ones that we're wanting to happen. And then the other thing we pick up on is the total outcomes, or possibilities. So those are the main things. So again, they didn't buy all 400 tickets. They only bought a part of those tickets. So that's going to be their winning possibilities is going to be the possible outcomes. Well, based on the question, there's 4 people and they bought 3 tickets. So 4 times 3, that's going to give me, 4 friends and 3 tickets. That's going to give me this. They have 12 possible chances to win. Over all the chances would be like 400. So 12 out of 400 would be their probability. And with most fractions, they're going to reduce. And as we mentioned before, on the GED calculator, there's a special button referred to as the N over D button that you can use to reduce fractions. So notice that calculator button seems to be very useful on a lot of the questions we've been dealing with. Now, again, if you're not too afraid of dealing with numbers, I can kind of see that, 12 and a 400 are both divisible by 2. So I could take a 2 out of each one of those. I know that 2 goes into 12 like 6 times, and 2 goes into 400 200 times. And since these are still both even, I can kind of take out a 2 again. I can take out a 2 again. And then, 2 would go into 6 3 times, and 2 would go into 200 100 times. And that's as far as that's going to reduce down to. So it's going to be, they're going to have 3 chances to win out of 100 chances. That's going to be the same thing as 12 out of 400 chances. So that's kind of what that means there in probability is, again, probability, you are allowed to use a fraction as a way to express it to start with. And remember, fractions can also be expressed as percents. So, they'd also have like a 3% chance of winning here because percent means per 100. So you could also, sometimes they may want to express the probability as a percentage. So remember, you can easily change fractions to decimals, and then you can also change decimals to percents rather easily. So just keep that in mind as we move into probabilities. This one, though, luckily they just wanted a fraction. So let's move on to another question. So again, we have another graph. So again, data, statistics, probability. There's going to be a lot of graphical information given. So again, we have here a comparison of online orders. And then we have what we call some line graphs. The blue line, the blue dotted line is company K, and the orange solid line is going to be company Q. So we have this, what we call a key code. This is sometimes placed in many spots. This one has it in the top. A lot of times they may be in the lower left or even, or the lower left and maybe the lower right. Usually it's the right or the top areas here. Is usually where it is up in this area here is where the key is. They try to stay away from this area over here. So on this side, we have the number of orders, and it kind of goes by thousands. And then they go by months across the bottom. So we have months there. So again, we have a line graph. There's a lot to absorb. So really, the best thing is just go over to the question and just see what part we have to focus on. So again, it just says, in which month did company K and company Q receive about the same number of orders online? So in January, company Q had 1,000. Meanwhile, company K had, it looks like around close to 2,500. We're trying to find out when they had the same. So basically what that means is that they have to be at the same spot on the graph. So this spot here is where they would have the same number of orders. And what that looks like is, it looks again right around 2,500. So looks like in March, they're going to have the same number of orders. So that's problem error actually does not require any math. It just requires you to be able to read the graph. So that's pretty much it on that problem. So let's see what else we have. So some of the status stuff doesn't seem hard math-wise. It's just you got to be able to read it. So again, we have the same graph on this next question, but the question differs. So they'll do that to you on the GED test as well. You may have several questions using the same graphic. So based on the trends shown by the data, what would be the best prediction for the number of online orders in July for company Q? So again, company Q is this orange line. And so we have January, February, March, April, May, June. July would be like over here somewhere. It's not represented. So what they're trying to do is get us to predict. So we're going to make our best guess based on the path of the graph. So based on the path of the graph, it's kind of going off in this trajectory right here. So I can kind of add on to it. Looks like it's going off to about right in that area there. So it looks like it's a shade under 6,000 based on the trend if we continue off in this direction. So looking at that, the 5,900 seems to be our best answer. So again, we have another question. Really, there's no actual math involved. It's just be able to read and estimate the numbers. So let's see what else we have here. So again, we have the same graphic. So let's look down at the question. We're kind of getting familiar with some of the graph. About 18% of the online orders in April at company Q are returned for credit or exchanged. How many orders at company Q were returned for credit or exchanged in the month of April? So again, we have this percent problem, which again, we can probably use the triangle model to do this. Again, we have the portion that they're talking about, the base amount, the original amount, or the whole amount, and then we have the percent. So when I do my model here, I just got to have to mimic what we know and make sure I put it in the correct spots. So 18% of the orders in April, so we know the 18% is going to go here. And it's talking about April. So it looks like we have to use this graph. And we're also talking about company Q. So company Q again is this orange one. And in April, it looks like we're at this spot here. So we have 3,000 online orders. And again, that's not what's returned. That's how many actual orders were done. So that's the base amount or all the orders. So 3,000 would go here. And then basically what we're picking up on again is this 18% is about returned. And that's what the question's asking. How many orders at company Q were returned for credit or exchanged? So that's what the 18% was all about. So the part that we're looking for is here. Since we have the base amount and the percent, remember those are side by side, which relates to multiplication. So using my calculator, I can just simply go 3,000 times 0.18 equals, and I get 540. So 540 items were returned. So let's see here. Got that. So 540 would be it. You know, nothing you could have done is you could have looked at 18% and said, well, that's close to 20%. So what I could also done is, you know, 10% of 3,000, if I said 10% were returned, remember 10% means just lose one decimal place, so that would be 300. So 20% would have been 600. So the answer's got to be around 600. But again, notice that 20% is 600. 18% should be a little bit underneath that. So 600 still falls off because 20% gives us 600, but what's given is 18%. So we have to be underneath that. So that also tends to be that 540 using the estimate. So we have a couple of things we could do. The triangle model is very effective, but some people like to use this 10% to work on getting an estimate. Let's see what else got here. So our next question is got like a chart. Again, the title is Westerland Weather on March 10th. So we have a bunch of information to go through. So since there's so much information, it's better to just come down to the question and see what we have going on there. So it says, what is the mean amount of precipitation in inches on March 10th for the areas listed in the table? So the precipitation is only this part of the graphics. So we know we're zero on that. And the other thing is we have to understand what the word mean is. Again, mean is on our formula sheet. So if I pull up my formula sheet, the mean, let me go ahead and clear that off again. That's distracting. So the mean is part of the formula sheet, and it says the mean is equal to the total of values. Let me try that again. Mean is equal to the total of the values of a data set divided by the number of elements in the data set. So basically what that means is total means to kind of add. So you add all the values and then you divide by however many values are present. So that's kind of what we have to do here then is the mean is to add all these numbers up. So I have to add this 0.45. I have to add that to 0.63. I have to add that to 1.34. And I have to add that to 3.53. Okay, 3.53. Yeah. I got to add to that 2.57. And I got to add to that 0.84. And then all this has to be divided by however many pieces of data there were. So there's 1, 2, 3, 4, 5, 6 pieces. 1, 2, 3, 4, 5, 6. So I have to divide that all by 6. So to do the mean, I have to add all the numbers up, and then I have to divide by however many numbers were present. So let's see what we come up with here using our calculator. I have to move that a little bit. So we have 0.45. I may have to actually look at the table because I have a hard time reading my own writing. Plus then 0.63 plus 1.34 plus 3.53 plus 2.57 plus 0.84. So that gives me 9.36, and then I have to divide that by 6. So it gives me then 1.56. So that answer then takes me to C, 1.56. So again, it's really hard to get an estimate, but I mean, we know like the 0.65 looks like it doesn't really look that good because most numbers are above 0.65. So I could rule that one out, but the other three really I'm not as comfortable with ruling out. So I really have to do the math, but you know, the mean is kind of the middle value as well. And, you know, 0.63 is not really the middle value. So it kind of falls off there a little bit. So 1.56 kind of tends to be more of where the middle is. So again, to find the mean though, you got to add all the numbers together and divide by 6 to get what we call that central tendency, what the numbers tend to be overall on average, if you will. That's the word we a lot of times use for mean is the word average. So looking at this question here, a spinner has 5 equal sections and they are numbered 1 to 5. What is the probability of spinning a number less than 3? So a number less than 3, express the answer as a fraction. So we have these fractional answers again. So notice that there are 5 regions altogether. So that's all the regions is the 5. So all the possibilities is the bottom part. And then the part that I'm looking for are what's less than 3. Well, there's only 2 numbers less than 3. Well, so like I said, we have 1, 2, 3, 4, 5. We have 5 possibilities, but only 2 of those are under 3. So my probability should be like 2 out of 5. So 2 out of 5 would end up being then B. B would end up being our result there. So again, understanding probability is the favorable outcomes for me, the possible outcomes that work in my favor, favorable outcomes, and then divide that by your total outcomes. So that's really important in picking up on is, again, the top is your possible outcomes, or another way we say it is your favorable outcomes. if I can spell favorable. So there are two outcomes that are in my favor. So that's what's going to be the top number in a probability. And then the bottom is going to be all the possibilities altogether. So 2 out of 5 would be our result. Let's see what else we got here. I think we got it. So that's a little bit of an idea of some of the data, statistics, and probability questions that you may come across. So stay tuned. We'll see if we can do another type of review. So hopefully you'll find that helpful for your GED test. Take care.